So working with polynomials, one of the things we pick up on is what's called a factored form and what's called a expanded form. So a minute ago, we were multiplying everything out using FOIL and the box method and things. We were writing as what was called expanded form. So now we're going to be given problems that are in expanded form, and we want to put them back in what's called factored form. So it's kind of where we are with this. So our goal in this lesson is to factor an expression containing a common factor. The way this is going to be done is this is going to be where we refer to as what's called the distributive property. So we're going to be dealing with that. Remember, distributive property is when we multiply through addition. So we're going to kind of do this backwards, though. This is going to be called factoring. So the multiplication problem, like we have, if we have a 7a times the quantity 3a plus 2, the 7a is considered a factor, and the quantity 3a plus 2 is considered a factor. So this is what's described as factored form. So notice how we start to see the appearance of parentheses again, because parentheses represent this factored form. So as we said, in this we have this 7a and this 3a plus 2. They're kind of grouped together as two separate factors. Now, if we multiply that out, we could write that as the sum of 21a squared plus 14a. So if we use distributive properly and multiply through the parentheses, 7a times 3a was 21a squared, and then 7a times 2 was 14a. This is what's called expanded form. So to rewrite the expression 21a squared plus 14a as indicated, in other words, if we write it as the product of 7a times the quantity 3a plus 2, this is said to factor it. So you're going to hear me use this word factor. So factor kind of means to rewrite this as an expression that represents multiplication, as opposed to things that are separated by just purely addition or subtraction. So if we look at the a times the quantity x plus y, this is described as factored form. And if I multiply the a through the parentheses, ax plus ay, that's described as expanded form. So our goal is to change expanded form back into a factored form. So, and we call this factoring. So the first way we're going to do this is to factor an expression is looking for a common factor. What we want to do is we want to find the greatest common factor of each term of each expression. And then we want to divide each term by the common factor. And we want to divide this mentally if practical. And then we want to rewrite the expression as indicated as a product of the greatest common factor times the remaining piece. So if I want to factor 4a plus 4b, to put that in factored form, notice how we have, again, this, this 4 times a plus then this 4 times b. So notice how we have these two terms. The 4a is the first term, and the positive 4b is the second term. What we're looking for is a common factor in those two terms. And notice how 4 is a common factor. So what we want to do is we want to factor that 4 out. So when I pull that 4 out, what we essentially are doing is dividing the 4a by 4. In other words, what's left then is just simply a. And then if I divide 4b by this 4, what that's going to leave me is a b. So when we pull out the common factor, it's no longer part of the inside. It becomes the outside of the factored part. And then the remaining factors are what's left. So notice how there's this common 4, and there is this common 4 on each one. Notice how we're kind of dividing that out, removing it. That 4 comes out here, and the remaining factors are that a plus b. So if we multiply that back out, 4 times a, 4 times b, that would put us back in this expanded form. But this is what we're looking for, is this 4a times this 4 times the quantity a plus b. That's considered factored form. So if I look at this expression 3ab plus 9a plus 12b, what I'm looking for is a common factor of all three terms. So what we're looking at is this 3ab, this 9a, and this 12b. So notice that the factors of 3ab, what we have are this 3, this a, and this b. The 9 has a 3 times a 3 times an a, and the 12 is a 2 times a 2 times a 3 times a b. So what we're looking for is basically what's called the greatest common factor or the greatest common divisor. So the greatest common factor or greatest common divisor, if you notice, is going to be just a 3, a 3, and a 3. They have that. This has an A and a B, but this has an A, but it does not have a B. So it has to be in common with all of them. So the B is not in common there. And this last one doesn't have an A, so I can't pull out an A or a B. So all we're allowed to do is pull out the common factor of a 3. So what I circled is what comes out. So a 3 comes out, and then in parentheses, we write what's not circled, which is going to be the AB plus then the 3A plus then, and I got to put that 2 times 2 back together, and that's going to become then this 4B. And that would be considered the factored form of that expression. So factored form, what we're looking for is a common factor or a common divisor, if you will. So when we pull that out, we're actually dividing it out, if you will. And a lot of times that's done mentally. So if we look at the expression 10a squared plus 6a, so mentally what you're thinking of is that a 10 is made up of a 2 times a 5, and there's an a, and there's this a. And then mentally you're thinking that the 6 is made up of a 2 times a 3 times an a. So mentally, what you're trying to do is what's in common. So mentally, we see that there is a 2 in common, and there's also an a in common. So what we're seeing is there's a common factor of a 2 and an a. So that 2a will come out, that common factor comes out, and then the remaining factors stay inside there. So that 5a remains inside, plus then just the 3. And that would be considered what we call factored form. So this is my mental thinking. So if I can't do that mentally, I can actually show it on paper as well. So if I look at 2x squared plus 4x cubed, mentally what I'm thinking of is there's a 2, there's an x, and there's an x. And then the 4 is a 2 and a 2, and then there's an x and an x and an x. So that's my mental thinking. So what I'm trying to ask myself is how many 2's do they have in common? So notice how they do have a 2 in common, and how many x's do they have in common? Well, if this has 2 and this has 3, they have 2 in common. So I have 2 x's in common. So what we come out with is a 2 times an x times an x. In other words, what we pull out is a 2x squared. 2x squared. Now, since I pulled all this out, remember, when I divide all that out, that leaves me with a 1 as a placeholder. Because remember, we're actually dividing out. If you divide by the same thing, that leaves you a 1. And you can also double check it. Does 2x squared times 1 give you 2x squared? And it does. And when I pull out the 2 and the 2x there, that just leaves me a 2 and an x on the inside. So 2x will be left there. So that's considered what we call factored form. So if we look at 2x plus 3y, notice how this has a 2 and an x, this has a 3 and a y. They don't have any common factor. So there is no GCF, if you will. So this is simplified as is. 2x plus 3y is simplified. There's nothing I can do with that. I cannot factor it. So this is kind of simplified. And sometimes if it doesn't have any common factors, we use that word prime, if you recall. Prime numbers cannot be broken down. They don't have any common factors in them. So we could leave that then as what we call prime. It has no common factors. So as you kind of notice, when do we use this one and when do we leave this one off? So when 1 is a term, it must be written. So notice how here x over x divides out, but since it represents a term, we have to keep the 1 in the problem. But notice how if it's a coefficient or a factor of a term, so notice how 2 over 2 becomes this 1a, and this 2 over 2 becomes this 1b. If they become coefficients, we are allowed to drop those 1s. So again, if 1 is a factor, in other words, if it's a coefficient, we drop it. It's not shown. Also, as an exponent, notice how if we subtract exponents, we end up with this power of 1. So if it's a power of 1, what we pick up on is that's understood. Just the same thing as x to the 0, we don't show that either. So we don't show either one of those exponents if it's a 1 or even a 0. That kind of gets dropped out. So sometimes a binomial factor can be, it's actually going to be a two-termed common factor. So if I look at this example 5, notice how 7y times 2y minus 2 times, or 7y times 2y minus 5, that quantity. So 7y is a factor and the 2y is a factor. So this is in factored form. And then we have this 3 times 2y minus 5. Notice how the 3 and the 2y minus 5 are factors. So what we pick up on is, in this case here, the 2y minus 5 is actually a common factor. So what we do is that common factor gets pulled out, or divided out, if you will. I'm just not showing that step, I'm doing it mentally. So we divide out or pull that 2y minus 5 out. Now what I need to do is show that in parentheses, because that whole quantity is a common factor. And then in parentheses, we write the remaining two factors, which would be the 7y plus 3. So that would be described as the factored form. So the common factor has to come out in parentheses, and the remaining factors, the remaining terms, have to be put inside the parentheses. So this becomes a factored form where we have a binomial times a binomial, and that's considered a factored form. Sometimes what we pick up on is if the leading coefficient is a negative, it's also very helpful to factor that negative out of the problem. So notice how if we have this negative 3x squared plus this 2x minus this 5, notice how they don't really have any common factors except that there's this negative out in front. So what I'm allowed to do is I'm allowed to factor the negative out of the problem. By doing so, each term has to change sign. So inside the parentheses, this becomes then a 3x squared. This plus 2x turns into a minus 2x, and this negative 5 turns into a plus 5. All the signs can change. So we're also allowed to keep the leading coefficient positive by factoring a negative out of all three terms. And so that means the signs of all three terms have to change. So this would be a way I could change this and make it look like this by pulling the negative out, or the negative 1 out, if you will. Alrighty, so that concludes a little bit on factoring with the GCF.